right, so we got 1/6 part 2 here, where it gets a little more interesting because we have 3 variables. And it's the double elimination method. I'm just scanning it real quick, deciding what I want to attack. And I think I want to attack B. For some reason, I don't like B. So again, I'm going to attack B. I'm going to take this equation and double it. I'm going to add it to the second one. Because I won't have any B left. And I have to do it twice because I have to have 2 equations that have just A's and C's. So the next thing I'm going to do is I'm going to multiply this one by a -3 and I'm going to add it to the top. That'll give me -12A. Again, remember, I like additive inverses. And I'm going to have -9A. I love the way this thing just worked out. See those two right there? Already additive inverses. What have I got? I've got a minus a C, a plus a C, additive inverses. And I got -23 and -75, which is -98. So let's take these 2 equations here and see what happened. And if I add down, I have no A, I have no C, and I'm a number here, which doesn't really matter what it is, but I'm -23. I technically have 0 equals -23, which is false. There are no solutions. And we would classify this as inconsistent. It is an inconsistent system, or it is a dependent system. Yeah, it's inconsistent, dependent. No solutions is inconsistent. These 2 things are not equal. It's also dependent. Zero equals 0 would be consistent dependent. So there you go. There's number 4. I really enjoyed this stuff as a kid when I first saw it, but again, I'm kind of a weirdo. This, by the way, is what linear algebra is. If you ever take a course on linear algebra in college, it's systems of equations, matrices, a whole bunch of other stuff, but mostly systems of equations and matrices. All right, we got number 5. And what do I feel like going after? Probably the Z's. The Z's looks easy to me. And the Y's would be a good choice too, but I'm just going to attack Z. You can pick any variable you want. I'm going to go after the Z's. So I'm going to go ahead and negate this equation and add it to the second. Make sure I didn't make any mistakes. I would have 9x plus 7y, no z's, equal to 39. And remember, you got to do it twice. Okay, so I've got to do it again. Maybe I shouldn't have picked z, but this time I'm going to take the top and multiply it by -6. I probably should have picked a different variable. That'll give me 36x plus 12y plus 6z equals what? 102? And I'm going to add it to this equation. Actually, it doesn't really matter which one you add it to, but I'm going to go with that one. Yeah. Yeah, I probably should have picked better. Okay, so this kind of stinks. I think I'm gonna go after the Y's because they're smaller. What's the smallest thing 7 and 13 both go into? Ugh. Well, apparently I'm having a senior moment here. So I guess what I'll do is I'll go with Old Faithful. I'll 13 that one and I'll 7 this one. That's what I'll do. All right, 13 times 9 is 100 and what? 17x. 13 times 7 is 81y. I'm going to negative 7 this one. And 13 times 39. Let's make sure I don't mess that up. There we go. She finally opened. This is weird. 13 times 39. 507. I did click that button a whole bunch. All right, now we got negative 7 times 41, which is negative 287. 7 times 4 is 28. Negative 7 times 13 is minus 81y. And then we got negative 7 times 121, which is negative 847. I think. Pretty tired. Start adding. What have I got? I got a negative 160x. There's no y. And that's not looking pretty, is it? Negative 170x. That's y. And negative 340. All right, divide out my negative 170, and x is 2. I probably should not have attacked z. You'll discover as you do these that some variables generate nicer answers. Now, there is still sadly a whole lot more work to do. I'm going to take this x and I'm going to put it there. 9 times 2 plus 7y is 39. This is 18. 39 minus 18 is 21. Y is 3. All right, so I have x and y. And I'm just going to feed this top equation. All right. You can pick any equation you want, doesn't matter. But I know x is 2. I know that y is 3. And I have a negative z equal to negative 17. So this is negative 12. Take away 6, which is negative 18, minus z is negative 17. I'm going to add 18. Negative z is 1, so z is negative 1. And there we go. Our ordered triple would be x, y, z. X was 2. Y was 3. And let's see here. Z was negative 1. A lot of work for 2, 3, and a 1. It is what it is. See if I can do one more before break. Is over? Yeah, I can do 2 more of these. Let's write the augmented matrix. Do not solve. I'm going to do 7 because it's harder. You have to get things in a particular order. Alphabetical order for sure. Alphabetical order. So I know the alphabet. It's L, M, N, O, right? So I'm going to leave M on the left. This is going to come over. Minus 7n will be equal to negative 1. Negative m minus n, we're going to move the 1 right, equal negative 1. Now I can write the augmented matrix. The augmented matrix is only the coefficients in front of the number. There's a 1 there, a negative 7. The bar means equality. Negative 1, negative 1, negative 1n, negative 1m. And there you go. All right, moving around. This is your x, your y, and your constant. I'm going to do 9. We would have 0.5x. Let's clear that. Bad looking 5. 0.5x plus y is 0. And negative x plus 4y is 2. Now I said clear the decimal fraction. I can do that by doubling. Because 2 times a half is 1. Doesn't change anything because I used the distributive property. I doubled everything, the left and the right. And there you go. And that's a good stopping point for this. There's not a whole lot left to do. There's 1 page. I just don't have enough time for it. So I'll have to do that during my planning period.